Previously, when we talked about how to solve a fractional equation, we recommended that multiplying both sides by the LCD to get rid of all the fractions. So you end up with the equation with only integers. There is a way that you can keep all the fractions, adding them, multiplying them. If you feel that you're very comfortable with adding fractions with the variables in there, you can do that. But this way is highly recommended by getting rid of the denominators. Now we're going to look at how to solve an equation involving decimals. It's probably doesn't make too much difference whether you are going to get rid of decimals or not. So I'm not going to recommend which way over the other way. You can do either way because really when you add or subtract decimals, it's not as hard as adding or subtracting fractions. Okay, so let's I'm going to teach you the new way. So let's try to do the new way. So the new way is, the idea is to get rid of the decimals if you don't like operations with decimals. In order to do that, because we notice that when we have a decimal number, any number, that you can multiply it by multiples of 10 to get rid of the decimals. For example, if we have, let's say, 0.78 right here, I can multiply it by 100. And I will get 78. So the quick way is whenever you multiply a number by multiples of 10, if there are two zeros, you're going to move the decimal point to the right. And because when you multiply a number by 10, a positive number by 10, the number is going to get bigger. You move the decimal point to the right, 78 is going to get bigger. So that's a quick way to do it. If you only have one zero, for example, if I want to get rid of the decimal in number 0.5, I can just multiply by 10. And because 10, I move the decimal point to the right, one digit, that gives me 5. Okay, but the thing is, when we multiply a equation, both sides of equation by a number, it must be the same number, and you cannot pick some of the terms, say this one we multiply by 100 and that one we multiply by 10. You can't do that. So it has to be consistent. So out of these two, 110, and we're going to pick 100 because when you multiply 0.5 by 100, you're going to move the decimal point to the right 2 times. We're out of digits. I'm adding a 0, so I can move it again. We end up with 50. You're still going to get an integer. So which means you always pick the one with more zeros, the larger one, the largest one. And because if you pick the smaller one, say out of 10, 100, I'm going to pick 10. And that's not going to get rid of decimal in 0.78 because you're only going to be able to one because you only have 1 0. When you move the decimal point to the right, you're going to get 7.8. It still has decimal point in there. So our goal is to get rid of all the decimal points in those decimal numbers. All right, so this is what we're going to do. We're going to pick 100. Now, a quick tip is we can actually just count how many digits. Say I have 2 digits here, 1 digit here, and 2 digits here. So 2 digits means 2 zeros. So out of the 1 digit and 2 digits, so we're going to pick the larger one, which is 100. Okay, now I'm going to write one more time here because it's going to be a little messy to do. So I'm going to multiply the first one, 0.78 by 100. In fact, we're supposed to multiply the entire left-hand side by 100, but I'm going to go ahead and multiply each term. So that's a term multiplied by 100 to save a step. And be careful right here, since it's multiplication between 0.5 and the parentheses, this is treated as one term. if you distribute 0.5 to x and to negative 0.5, you're going to get two terms. But if you don't want to distribute them, distribute 0.5, this is considered as one term. If you only have one term, you can only multiply one number, 100. So don't try to multiply 0.5 by 100 and then x by 100 and 0.4 by 100. So it's because this whole thing is treated as one term. Okay, so let's look at that. If you still get a little bit confused about the explanation here, you can ask me. So let's look at, so let me finish the process and I may explain a little bit later at the end. Okay, now remember, we're supposed to multiply every term by 100. So that's a term because it's multiplication, that's one term. On the right hand side, we got two terms. 2x, multiplication between them, so that's treated as one term. But minus will separate the terms. So this is our second term. Now I'm going to multiply 100 and 2x and 100 and 3.65. So now when we multiply 100 and 0.78, move the decimal point to the right side 2 times. Again, gives us 78. Be careful here when we multiply 100 and 0.5. We only need to multiply 100 and 0.5 to get a 50. You can't distribute 100 to 0.5 and then distribute 100 to x and to 0.4. The reason is whenever you need to use distributive rule. So for example, when you distribute a number and it has to be addition or subtraction, x plus y or x minus y inside the parentheses. And on the outside of parentheses, it's multiplication. So you can distribute 3 to whatever inside the parentheses. If I change this plus or minus sign to multiplication, let's put x times y there instead of x plus y. You're not going to be able to distribute 3 anymore because distributive rule is only applied to multiplication and addition. Okay, it's not applied to two multiplications. And so let's go back here. So because it's multiplication here and a multiplication there, you cannot distribute 100 to both 0.5 and the parentheses. You can only use it at one time. So two multiplications, I follow the order from the left to right. So 100 times 0.5 is 50 and times by x minus 0.4. But for that part, we do have to distribute 50 because there is a minus inside parentheses. Well, before, but when you look at 100 and 0.5 and x minus 0.4, these three, so first number is 100, second number is 0.5, and the third one is a parenthesis. You look at this as a whole thing, and you don't distribute it because it's multiplication here, multiplication there. Okay, now move on. So 100 times 2x, 200x, and 100 times 3.5, move the decimal point to the right 2 times. We get 365. To get rid of the parentheses, we distribute 50 to both of them to get 50x minus. Now 50 times 0.4, it's going to be 20 because first you do ignore the decimal point. You get 4 times 50, which is 200, and because there's a decimal point, you put it back. So the way we do a multiplication of decimals is decimal numbers, you can ignore the decimal point and to just multiply whole numbers, you get 200. But then put the decimal point back. There's only one decimal place. You put it back and that gives you 20. All right, now next we're going to keep doing this. So we can combine like terms, 78 minus 20, which is 58, and plus 50x equals 200x minus 365. I'm going to move 50x to the right side. Let me erase this part. And now we're going to get 58 on the left. So subtract the 50. When you move 50x to the right, it's like to change the sign to negative. Get 150x minus 365. Now, we keep the variable term on the right. We're going to move the constant to the left. Okay, or you can add 360 both sides. That will cancel that. So we have 423 on the left and 150x on the right. And final step, we divide both by 150 to get x equals. Use the rule we learned before to quickly check that whether 3 goes into the top, because we know 3 goes into the bottom. 3 goes into 15. Of course, 3 goes into 150. But 4 plus 2 is 6. 6 plus 3 is 9. So we add all the digits. If you remember, forget this rule, you can go back to watch the previous videos. So we divide both by 3, because 3 goes into the sum of all the digits, then 3 goes into the number. So we can reduce this fraction to the top will be 141, and the bottom will be 50. And notice that the only number that can go into 50 is 2 and 5. Prime numbers and 2 and 5. But 2 doesn't go into 141, 5 doesn't go into 141 either, because it does not end in an even number, and it does not end in 0 or 5. So that's the reduced answer, 141 over 50. Now let's look at the second one. Now in this case, we are going to, it looks like, so here we have 2 decimal places, and we're going to multiply 100 again. So multiply 100 here to save some writing. I'm just going to multiply 100 here and multiply 100 on the right side. Now 100 times 4. So first we're going to multiply the first 2 numbers. Notice it's 100 times 0.4 times another one. So when you do multiplication, you just follow the left to right order. 100 times 0.4, move the decimal point to the right. That gives us 50. Because there are 2 zeros, we're going to move it to the right 2 times. And similarly, 100 times 0.3, that gives us 30. And on the right-hand side, move the decimal point to the right 2 times. That gives us 274. Now we distribute 40 to both of them. So we get a 40 times x. And a 40 times 0.6. Ignore the decimal point. 40 times 6 is 240. And put the decimal point. That's 24. And next, we do negative 30x. Distribute. Also be careful. When you distribute it, you must distribute the sign in front of it. So that's negative 30 times 2. That's negative 60 equals 274. Let's combine these 2 x terms, 10x, and then combine these 2 constant terms. So it's minus 84. On the right, it's 274. Now let's move the number to the right side, either by changing the sign or by doing the opposite operation. And we have 10x equals 358. And divide both sides by 10. Okay, now you're going to have x equals, notice that 2 goes into 10, so let's divide both top and bottom by 2, and 2 also goes into the top. So I get 5 on the bottom and 179 on the top. Okay, so that's the final answer. You can leave it as a fraction. But be a little bit careful here. If in the homework there'll be a minus sign here, so you need to make sure you don't forget the minus sign there. Okay, but if you say I feel comfortable multiplying decimals or adding, you can leave all the decimals. For example, in this question, you can just distribute a 0.4 to both of them. So you're going to get a 0.4x, and then 0.4 times negative 0.6. That gives you minus 0.24. And then you distribute a 0.3 to both of them. That gives you minus 0.3x and minus 0.6. on the end, you just keep that decimal number 2.74. And next, when you combine like terms, you keep those decimals.